In this lesson, we are going to use what we've learned in the previous lesson, and we are going to use the particles to create something really cool. We are going to create a galaxy generator. It's not just creating a galaxy, we are going to let the user create its own galaxy by tweaking parameters in the debug panel, which is even better. So what we have in our setup, well, it's just a cube. We haven't much. It's some kind of a basic setup we have until now. We already have our .gui, so I won't explain how to import and instantiate .gui because we did it multiple times. And we are going to fill that debug panel with a lot of tweaks to create a galaxy. And when the user will play with those tweaks, a new galaxy will appear. Okay, cool. So first, we can get rid of the cube. So yeah, you can just remove it here. And we are going to create a section about galaxy, like that. And we are going to first create a function, which will be called generate galaxy, because we will just call this function to generate a new galaxy. So let's go, const generate galaxy. As always, you can use the old-fashioned way of creating functions by doing function generate galaxy, but I prefer to use the fat arrow. And you can call it right away by doing generate galaxy. This way, when you open the page, you get a galaxy with the default parameters. And we can put a log generate the galaxy like this. All right, it's working. We don't have the cube anymore, but no error, and generate the galaxy in the console. Great, let's move forward. So as I said, we are going to have a lot of parameters, all right? So you can create an object parameters. I like to put all the parameters inside one object, and this will be really useful because as you remember from the .gui, the debug panel lesson, we need an object in order to add tweaks to that GUI. We need an object, so it's going to be our parameters object, and we are going to put everything in it: color, size, radius, spin, and other things. So that's cool, and we can start already by creating parameters count, and we're going to use 1000. All right, so parameters with an S. So it's the first parameter, and we are going to use that parameter to create 1000 particles. And if it's something like 10,000, well, it's going to create 10,000 particles. We are going to add this property to the tweaks, to the debug panel later. So let's go. This is the part where if you want to practice alone in order to test if you understood well and you remember well, you can do it. What we are going to do is create 1000 by using this parameter, so 1000 particles all around, so it's just random, all right? No galaxy shape or stuff like that. We just want 1000 particles placed randomly. Be careful, it's still hard. It's okay if you can't do it. I always struggle even for those kind of things, but it's good to practice. But now I will do it with you. So first, we need a geometry, a material, and the points, all right? The geometry, we are going to create one, so we are going to use a buffer geometry so that it's empty and we fill it with the positions. The material, we are going to use the classic point material, and for the points, well, it's going to be the points class. But let's start with the geometry. So const geometry equal new 3 buffer geometry. Always use buffer geometries. There is no reason to use other things now that we know how to use buffer geometries. If you remember, we need to add attributes to the geometry, and we are going to create a position attribute. But first, let's create a positions array, and it's going to be a new float 32 array. So a float 32 array like this, which is this special kind of array we saw earlier. Parameters count, so we are using the parameters here, and we multiply it by 3, because remember that each vertex is going to have x, y, and z values, so we need 3 values per vertex for the positions. All right, cool. Then we have to fill it with random values. Let I equal 0, I inferior of parameters count. I know I didn't put the multiply by 3, you will see why. I plus plus. We're going to do things a little differently for good reasons. And then we fill the array. But if you do like we did before, just that, you will have a problem because you will fill only a third of the array because our array is this long. And right now we are looping this long. All right, so we will fill only a third of this array. But still we need to do that because right now we are not, after that, we are not going to put any values in this. We are going to put the values for each vertices for our galaxy, and we will want to place them at a very specific position. There will be a randomness too, but it will be at a very specific randomness. So we have to think of the vertices like one vertices by one vertices, not just fill the array with random values. So what we are going to do now is fill the x, y, and z in this loop, all right? To do that, we are going to use the same technique as we did in the previous lesson. We are going to use a I3 index, which will be the I multiplied by 3. I multiplied by 3. This way we get 0, 3, 6, 9, 12, etc. And we are going to fill the array 3 by 3. So it's going to be I3 plus 0 equal math random I3 plus 1 for the x. This one is for the x, this one is for the y, and this one is for the z, like this. Okay, cool, I think it's fine. You can test this array. Do not worry, I know it's a huge array. We have 3,000 value in it. You can log it. Chrome can handle it. See, you get a huge array, but Chrome only gives you a preview of this array. And you can open it. You have the small arrow here. You can open it and you will get chunks of this array. And if you open this chunk, you can get the values in this chunk. All right. Thank you, the Chrome dev team, for doing this. Instead of just freezing the computer for like 2 minutes, you get just chunks of the array. Go to the end, and as you can see, I have random values everywhere. It goes from the 0 to the 3,000 because I have 1,000 particles and I need X, Y, and Z. So yeah, everything is fine. You can log huge arrays. And I'm quite sure Firefox can do it too. All right, we have our position array. Let's add an attribute to the geometry. Geometry set attribute. We need a name, so we'll put line breaks just to be able to put everything on the screen. Position. So position, new 3 buffer attribute. So it's the way of adding buffer attributes. We use the positions array, so our float32 array, and we specify how many values per vertex, and it's 3 because X, Y, and Z. No drawings for this part this time. We save, still no error. If you have errors, check maybe you did something wrong. And check if the error comes from your code. Sometimes it's just plugins and stuff like that. All right, that's cool. So as we said, we did the geometry. What you can do is create huge chunks of codes. So I'm going to use this my technique to create those, to separate more easily because we are going to have a lot of code. Then the material. For this part, you do whatever you want. Commenting is not that important when it's just exercises, but if it's a real project, always comment the right way. Points material. So if you remember from the previous lesson, this is the way of creating a material for the particles. And we are going to put few parameters, and we know them. We are going to use the size, and we need the size. So by the way, I forgot to add this. So the size, we are going to provide a new parameter here. So it's going to be size. And we will start with 0.02. And as always, this will be tweakable. All the parameters here will be tweakable from the .UI panel. So add the size 0.02, get back to the material and use these parameters. All right, we always use the parameters. Then size attenuation, yeah, we want it. Not necessarily, but in our case, let's use it. Did I wrote it well? Yeah, I did. We are going to deactivate the def right. I won't explain it. You have to go back to the previous lesson if you need more explanations about this. And we are going to activate the blending because it will look better. Like when we will have a lot of vertices at the center, you will see that it will look bright, almost white, because the colors will add to themselves and we will get a really cool result. Like if it's burning saturated where there is a lot of stars for our galaxy, a lot of particles. Additive blending, like that. We save. Still nothing on the screen, but no error. Check the errors. Don't do like 100 lines of code without checking the errors, even if you don't have a result. And then finally, we can add the points. So I will call it, I don't know, points. And I will do const points equal new 3 points. And like a mesh, we need to provide a geometry and a material. So let's go. We are going to use the geometry. So it's this one. And then the material, it's this one. I save, nothing. What did I forget? To add to the scene. Scene add points. Yeah, this one I did it on purpose, but I forget so many times. All right, that's cool. It's working well. We have the particles. It's not centered. If you want to center them, it's not the point of the lesson because we are going to create a galaxy. Remember that we can do minus 0.5. So now it's centered, okay? And we can then multiply by something bigger, let's say 3, and we get the particles looking like that. Okay, looking great. But we are going to get rid of this shortly. All right, so we have a base. When we have a base, as I told you in the debug lesson, it's always good to add the tweaks when you progress. All right, don't wait for the end of the project to add the tweaks. It's a bad idea. You will miss a lot of opportunities to discover cool things and find the right parameters. And you probably get too lazy and just say, oh no, it will take hours to add all those tweaks and you won't do it. So we are going to add the tweaks and we're going to do small mistakes, but we will fix it shortly. To add the tweaks, remember from the debug lesson, we have to do GUI because it's our instance of that GUI. Add, then you provide the concerned object. So it's parameters in our case, and then the property as a string. So we are going to start with the count. So count, then you can provide a minimum value, a maximum value, stuff like that. We can provide those here in the parameters, but I like to do it there by chaining the method like that. Max, we are going to put this one. How much? Yeah, that's a lot, 1 million. And the step, I want to go 100 by 100, which is probably even too small. We are going to have a lot of stars in our galaxy. For the size where I want to be able to do really small stars, the maximum, let's test 0.1. We can get back to those tweaks later. It's not, you can always change those. And as the step, usually I use the same as the mean value, which is kind of logical, but you can put any step you'd like. We save and we get those. Great, so we have our tweak, let's test, and no, it's not working. And it's kind of obvious. Actually, you can also crank this, the width up. If you remember, you can do width and put something else like 400 and you see that it's bigger, all right? So don't hesitate to do it. I will put a little less, yeah, like that. So I can easily tweak the values. So yeah, it's not working. Actually, it's working. It's doing exactly what it's supposed to do. It's changing those values, all right? But those values are never used again. They are used once to generate the galaxy in this function, which is called only once, but then they are not used again. All right, so we change the value, but we are not using them again to generate a new galaxy. So to generate a new galaxy, we have to call the generate galaxy again. All right, To generate the galaxy again, we have first to listen to the change event. And we have two ways of doing this. We can do onChange and use a function in the parameters here. But this would be a bad idea because when you will just change the value like that, you will generate 100 galaxies. It will be probably too much for your computer, at least too much for my computer. So avoid using onChange. Instead, we are going to use onFinishChange. This way, when you're doing this, look at my tweak. Right now, it's not generating anything. And when I stop, I just stop drag and dropping this value, it will call the function, which is probably better in our case, so that we don't use it too much. And we pass as the parameter generate galaxy. All right, careful, it's a long line, but you can pass the generate galaxy right here. I saved, I get an error because I did a mistake. I tried to pass a variable named generate galaxy to .gui, but this generate galaxy doesn't exist yet because I instantiate the variable after. All right, it's just a JavaScript error. I have to take this code and move it after, all right, after the function or after the call of the function. And now the generate galaxy will exist and I can just pass it to the onFinishChange. All right, it was just a JavaScript error. Okay, it seems to be working, but we have a small problem. If you change the value, be careful. I'll stop you right now. Do not change too much the values. All right, just click a few times. All right, it seems to be working. All right, and if I want less, it's not working. Don't click too much because there is a problem. Currently, we are generating new galaxies, but we are not removing the old galaxies. So don't click too much, or you will freeze your computer. You will crash your computer. We have too much on the screen. You will have to force quit Chrome or something like that. So don't click too much. I test again. Look, I changed the size. It creates a new one with the right size. New one with the right size, new one with the right size, but we don't remove the old ones. They are still in the scene. So we need to find a way to destroy what is already in the scene. And it's the perfect opportunity because I wanted to show you how to destroy things properly, at least what we have currently. We need to destroy the geometry, the material, and the points. At least we need to remove them from the scene, but we will also learn how to dispose of things, remove things properly. First, what we are going to do is move the variables, so the geometry and the material and the points variable out of the function. Why we are doing this? Well, it's because here, at the beginning of the generate galaxy, we will test if there is something in those variables. So we will test if there is something in the geometry variable, if there is something in the points variable, if there is something in the material variables. But if they are not creating outside of the function, well, obviously they won't exist, so it doesn't make sense. So first we are going to move them and use a let because we are going to change them. If you use a const, the variable is a constant, so it won't change. If you use a let, it's because the variable is going to change. In our case, it's going to change right away. So geometry equal new, so I put nothing in it. You can do that. All right, you can just do that. It will work, but I prefer to do that so it's clear. It's not something that someone forgot. It's intended. So we have geometry, material, and points created outside, and in here, instead of creating again those geometry, material, and points, you remove the const. So you do it for the geometry, for the material, and for the points. This has nothing to do with Three.js. It's just about organizing our JavaScript. So we get the same result, meaning that currently we have geometry, material, and points to new. Then we call the generate galaxy, and in the generate galaxy, in this function, we change those variables, so geometry, material, and points. Great. Why we did that? Well, it's because in here, before creating those, we can test if there is something in those variables. And if there is something in those variables, we will destroy these, all right? So what we can do is just test one. We are going to test the points. So if points is different from new, we will destroy things here. So what you can do is destroy old galaxy, which is kind of dramatic. Star Wars stuff going on here. What we are going to do is geometry, dispose. And this is interesting. This is a method provided by 3GS, and we can test it. So 3GS geometry, so I'm going to use buffer geometry. Let's have a look to the documentation. And we have a dispose method. And this will free the memory from that geometry. So it's good to always dispose. If you have too many geometries that you don't even use, but you keep adding geometries, you will saturate your computer, the memory. So it's good to dispose of things. And we can do exactly the same with the material. Material, we save a lot of things in the memory. So we dispose the material in order to clear the memory from those. Obviously, the material won't work anymore, but that's the point here. We want to destroy the previous geometry and the previous material. And finally, you cannot dispose of a mesh because a mesh is just a point, but also mesh. It works the same for the mesh. It's just a combination of geometry and material. So there is no such thing as a memory usage, not really, at least. So what we just need to do is remove the points from the scene. And to remove things from the scene, just like we did add something, we can remove something, and we will remove the points. All right. This is the right way of doing this. Make sure that if you have a WebGL experience with a lot of things being created and then removed, make sure to always clear everything, all right? Or you will have memory leaks, stuff like that, and you will have frame rate issues, performances issues. So always do those kind of things, and yeah, that's all. So let's test. If I change the size, you can see that it seems that I don't have more particles, so it seems to be working. And if I create like a lot of particles, all right, it seems to be working. And then I move down the value, I get less particles because the old galaxies are being destroyed. Great. Yeah, we are not going to put textures on our stars. We could have. Actually, we will do something like that later, and we will create our own texture by drawing in GLSF, by using shaders. Well, it's way later. For now, we will just use squares, but the squares will be so small and there will be so much of them that seen from far, you won't see a difference, all right? So sometimes it's better to use just squares. It's actually better for performances too. Okay, cool. Let's tweak the values a little. We are going to use 100,000 particles, so change the count to 100,000, and slightly smaller particles that look like this, all right? And obviously you can tweak those. If you want to follow me on the lesson, just use those values, but you can tweak and find your personal values. All right, let's get serious and create the shape of the galaxy, all right? We will create a spiral galaxy. There is many types of galaxy. I'm no expert in galaxies, but we are going to create a spiral galaxy. So this is the center of our scene, and we will create a spiral galaxy. By that, I mean something that looks like this. Oh, no, that was a heart. That looks like this, all right? Spiral galaxy. And we are going to fill it with a lot of stars. So it will look something like that. Okay, looking great. Cool, so let's go. It's going to take time. Hang on. It's not an easy task. It takes hours to get a good shape. It took me hours to get what I wanted, but I'm going to explain to you, and it's not going to take hours. There will be a lot of math, all right? But I will try everything I can to explain to you those math. So first, as you can see, there is a radius, all right? If we take the center of the galaxy, which is right here, we have a radius that's somewhere like that. Okay, so we need to establish this radius. So this one is not that hard. We are going to add a new parameters to our to our parameters object, it's going to be parameters radius, because it's the radius of the galaxy. And let's use 5. Yeah, I think it will be fine. And when you add a new parameter, add it to the debug panel. All right. 0.01, so we can have a really, really small galaxy. 20, it's a maximum, it will be way enough. And we can use the minimum value as the step. And when we finish changing this tweak, we call generate galaxy. All right, if I save, I get the new radius and it generates a new galaxy. But for now, we still have our random values, so it's not working. Okay, what we are going to do now is create the vertices, and we are going to create them in a straight line, meaning that instead of trying already to put things in the right position, it's too hard. We need to go step by step. In that case, I think the best solution is to start by positioning the particles on that line, right? Starting from the center and then put the particle randomly on that line, all over there, okay? You can do differently. There are maybe better solutions, but let's follow this solution. So we will put them here. Then we will place them all around, but for now, let's put them in that straight line starting from the center. Okay, let's go. So go to your positions, and instead of those random value, we are going first to create, I think it's a radius, a random radius. So we use the radius of the galaxy, the radius parameter, to get a value from 0 to the radius. Okay, let's go. I'm going to call it radius, so it's the radius of this particle, equal, and I'm going to do math random, because I want them to be positioned randomly on that line. So some will be at 0, some at 1, and a lot of between. And we can do multiply by parameters radius. So right now we get something between 0 and 5, and it will be random. And then we can position them, so it will be on the x-axis, so the one going to our right mostly. So I just use this one. So this is the x, this is the y, this is the z, because we go 3 by 3. And this, I don't want to think about those yet. We just put 0, because we want them on a straight line. Like this, we have our straight line looking great. If I have less particle, maybe we can, yeah, you can see the stars. So this is our stars, because we have a lot of stars where you can see only a straight line. But if I crank them up, yeah, you see, we get something like that. And if the radius is smaller, we get that. So it's a tiny, small galaxy. And if the radius is large, we get something like that. It's a huge galaxy going really far. All right, that's a good start. Next, we are going to create the branches, because having this straight line is a good start, but we need branches. To create the branches, I want, let's say the user asked for 3 branches, where we want maybe one here, which was the right position at start, and then one here, and then one here. And as you can see, the galaxy gets divided by 3, because we said 3 branches, and the 3 branches must be I don't know the terms in English, equireparti. So it's the same angle between them. Okay, let's do that. And this is where the things get a little more serious. Hang on. There are many ways of doing this, and I will show you my way of doing this. First, let's add parameters. This one is easy. We add branches so that the user can control how many branches he wants. So I use 3. Then we can move to the tweaks, do branches, minimum 2. Yeah, I think that's logical to have at least 2 branches in a galaxy. Maximum 20. If you want more, you can crank this value up. And step 1. All right, we don't want 1.5 or something like that. We want 1, 2, 3, 4, 5. Sorry, 2, 3, 4, 5, 6, 7, 8, etc. So, okay, it seems fine. Let's test the tweaks. You see that I get a round number because the step is 1, which is great. Okay, I will do some drawing, some calculations to explain to you this part. I really like to do that, but I also have to explain to you how it works. So, as you know, what I like to do is to have things that goes from 0 to 1. Currently, what we have is I that goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So it goes really far. We are going to use this to position the branches, to position the particles on branches. And if it's 0, I want this branch. If it's, I will use another color, I will remove it after. So if I is 0, I want this branch. If I is 1, I want this branch. If I is 2, I want this branch. If I is 3, I want this branch again. Follow me on this. Then this branch, then this branch, then this branch, then this branch, then this branch. By using the I. So how can we go from a value that goes from 0 to, I don't know, 10,000, something like that, to 0, 1, 2, 0, 1, 2, 0, 1, 2. So this is the first step. So I have a value. I will say 0, 1, 2, 3, 4. We need enough. 5, 6, 7, 8, 9. I think it's enough. 10. Okay. I want this. What I want now is to have 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, I want this. 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. How can I get this? Well, I'm going to use modulo 3. What is modulo? Maybe you've heard of it. Maybe you use it differently. I won't give you the exact definition of modulo because I don't like the definition. Like when I learned in school modulo, it was hard. It didn't mean anything. I will show you the way I use modulo and you will just understand. Well, actually, it's just that. If I use modulo 3, I get 0, 1, 2, and it never reaches 3 because I use modulo 3. And you can just use modulo like that. So it gets back to 0. 0, 1, 2, because I use modulo 3, I can't reach 3, so it goes back to 0, and we get 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. And this is the way I use modulo. If I use 10, I will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will work as a good start. I just have a value that do 0, 1, 2, 0, 1, 2. So that's a good start. You will see how we are going to use that. I'm going to create, I think it's a branch angle. Yeah, we can use that. Branch angle, which is not right, or it will be fine. Branch angle. At the end, I want an angle. Yeah, by the way, the ultimate thing I want is this angle. All right. So for the first one, the angle will be 0 because it's the first branch. So if it's 0, I want 0. For this one, I want the right angle here. And for this one, I want the right angle here. Okay, so at the end, I want an angle. So I will start with I, modulo, not 3. We are going to use parameters, branches, because if it's different from that, we need to change it. Do not log this value because we have way too much particles. If you want to see what's inside this value, what you can do is if I inferior to, I don't know, 20, and then you log it inside of that so that you don't get like billions of logs and you crash your computer. You just do a test like if I is below 20, log branches. And what you can do is log two things. I'm going to log I and branches angle. And I get, so for the 0, we get 0, 1, 1, 2, 2. For the I3, we get 0, I4, we get 1, I5, 2, and then again we get 0, 1, 2, 0, 1, 2, 0, 1, 2. All right, and if we have, let's say, 4 branches, I get 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Cool. That's a good start. We have something that's getting close to what we want. And as you know, me, I don't like values that goes from anything to everywhere. I don't like that. Me, I like values that goes from 0 to 1. And in our case, we don't want to reach 1, but I will get back to this shortly. So what I want here, instead of 0, 1, 2, 0, 1, 2, I want something that goes from 0 to 1. All right, this one is supposed to be here. So the limit is going here. What I want exactly is 0, 0 point. So I'm going to use just point 33. So 33, 3, 3, 3 because it's a third. Here I want point 66. And then again, I want 0. So point 33, point 66, 0. I have to write it. 0, this. To do that, there is no secret. I will just divide this value by 3. So I divide by 3, because 1 divided by 3 gets you 0.33. I know we can't reach 1, but that's actually better, because if you reach an angle of 1, it will be like one circle. So you have the first one going there, and you have the second one that will go there, and the third one that will go there again. So we don't want to have 2 branches at the same place. So this is perfectly normal. This is a good value. All right. So we have to divide it by the branches. So we can just do divided by parameters branches. And the question is about priority, calculation priority. We want to divide this whole thing. Don't try to guess it, just put parentheses, all right? We get the result by I modulo branches, and we divide this result, so we put parentheses, so there is no question like which one is the priority. Is this the divided or the modulo? We don't care, we put parentheses. All right, let's test the value. Why did I remove my log? That was done. Let's put the value back. So if I inferior to 20, and we are going to log this value, so we're going to log in branch angle. Yeah, that's right. So we get 0, 0.33, so it's a third, then it's 2/3, and 0, 1/3, 2/3, 0, 1/3, 2/3, 0, 1/3, 2/3. So we get a circle ratio like that. What we need now is radians, and we are going to use pi, and it's pretty easy. If you remember, how many pi's do we need to do a full circle? When it's 2 pi's. All right. This is, I can do a drawing again. We are going to use, I use too many colors. Yeah, I did wrong with the colors. Anyway, it's not, it's okay. This is pi. All right. If you want to do a full circle, you have to use pi times 2. That's all. Okay. So I remove this. I can show it to you there. I won't be able to know to know the exact result, because pi, I don't know why, it's 3.14159, something like that. So we just multiply by pi, multiply by 2, and I'll get the angle that I will be able to position things here and position things here. And the first one, we have 0 multiplied by anything, you get 0. So the first one will always be right here. Okay, that's cool. So we multiply by math pi, multiply by 2, like this. We save, so I keep the logs this time. And what do we get? 0, 2 point something, 4 point something. I think that's great. I think that's good values, because a full circle will be something like 6 point, I don't know, 4 something. So we are close to it. So yeah, it's 1/3, 2/3 of a circle. So it seems to be good values. So right now we have the angle. It's time to position things on a circle. All right. We have the angle. So we have this value, the red arrow, the red rounded arrow here. We need to position things, and it's about positioning on a circle. And to position things on a circle, you have to use this angle, and you have to use this angle with a cos on an axis and a sin on the other axis. And we are going to do that right now. So let's go. It's going to be the x and the z. We are not positioning thing on like the elevation up and down. So it's on the x and on the z. For the x, I'm going to use math cos, the angle. And for the z, we're going to have a funny result, you will see. I'm going to use math sin, the angle. And you will get something like that. You have 3 stars in your galaxy. Crank the value up if you want to see them. So we get this. At least we have a good positioning. I mean, it seems that we have our 3 branches, but all the stars are locating in here. It's because our circle, we are positioning thing on a circle which has by default a radius of 1. When you use math cos and math scene, you get position on a circle which its radius is 1. We need to vary the radius, and we already have the radius right here. So we just need to multiply this one by the radius and this one by the radius. And we get this looking good. It's exactly what we wanted. We are positioning things in the branches. And you can add more branches and it will look like this. All right. We have way too many particles, which is why we see lines like that. I can maybe move a little less. Yeah, you see that the particles are positioning right. Okay, looking good. We can remove the log. Maybe I will regret later, we will see. And let's move forward. Yeah, what we need now is to focus on the spin. Yes, we need randomness too, but I prefer to add randomness at the end so that I can just focus on the base shape. If you add randomness, you won't be sure that your shape is right. So just first start with the base shape and then add randomness. So yeah, let's add the spin. We want things to rotate. I'm going to add the parameter here. I'm going to use spin, could have been spin angle, something like that. Anyway, it's not that important. So it's spin. I want my spin to be able to be positive and negative. So I want my branches to do like this, but also at the opposite. So I'm going to add spin. The minimum value will be less than 0, so it's going to be -5. The maximum value, I don't know, 5. Otherwise, you can just test tweaks. I think they will work fine. And as you can see, by default, it's 1, so it will spin a little, and I will be able to move it back or forward. Okay, cool. So let's use the spin, and it's actually easier than what you might think. First, we want the particles to spin depending on the distance. By that, I mean that if we have a spin value, we don't care what is exactly this spin value. If we have a particle here, we don't want this particle to spin too much because it's close to the center. But the one further from the center, so this one's supposed to be here, will spin a little, all right? The one supposed to be here will spin more. It will get there. The one supposed to be here will spin more. It will get there. The one supposed to be here, so the further from the galaxy, the more spin effect we'll have on this one. The one supposed to be here will end up here. And as you can see, we get this shape. So we get a spin. And if the spin is stronger, well, this one will end up here. This one will end up here. This one will end up here. And we get a more spin like this. All right. We can get this or this. So it depends on the spin value. Okay. So let's use those principles. We're going to create a new angle. Why not? It's just to prevent having too much in one angle on one line. I like to separate with multiple variables. I know it's more work for the CPU because the JavaScript has to create more variables, but at least you get a clear code. So we multiply the radius by the parameters spin. Because the further away from the center, the more spin we want. So we just take the radius of the particles, all right? It's not the parameters radius. We are taking the radius of, let's say, this particle, and we multiply it by the spin value. So this one, we have a small spin, maybe it will get there. And this one will be we will have a lot more spin, and we get around here. And this way we get that shape, that spiral shape. Then we can use that spin angle. We can add it to the branch angle, but I really like to separate the different values. So we just add it here when I'm using it. By doing plus the spin angle. We have the branch angle, we add the spin angle and see the result. Yeah, that looks great. I can do like psychedelic, yeah, you will fall asleep. All right, the other direction is even worse. Ooh. Okay, that's not the point. We can play with the tweak, and as you can see, if you tweak more, you get something like this, which is really great, looking really cool. You can go to the opposite, and you can have like a galaxy with not many spin, not much spin. Okay, that's fun. It's time to add randomness. It won't be that easy because we will have a problem. First, let's add parameters to be able to control the randomness. So it's going to be randomness equals 0.02. sorry, 0.2. We can add it to the debug panel. So it's going to be randomness. The minimum will be 0. Yeah, why not? It's strange to have no randomness, but anyway, let's be able to do it. 0.01, and we generate the galaxy again. All right, so we have our randomness tweak. Looking good. And we will use the randomness in the code. And what we will do here is to calculate the randomness here. Let's start gently. We will do randomness for each axis. So random x equal math random multiplied by the parameters. Nothing too harsh now. Randomness, so it's something like that. Did I write it? Yeah, it's right. Then the y, then the z. We don't use the same randomness for every axis, or we will get some strange line, so it's not the point. So we get a random value for each axis, and we add those random value to the position. So here we add, sorry, not spin angle, random x. Here we add random y, which makes no sense to do 0 plus random y, so you can just write random y like this. And here we add random z. And we get something like this. All right, it seems to be working, not very convincing, but if you crank the value up, yeah. The first problem we have, I don't know if you can see it, if I remove maybe some spin angle, do something like that, is that the randomness, see, it's always positive. All right, it's starting there. Look at this point, and it's always positive, and we get something like that. So first, we need our random value to be able to be as positive as negative, and we are going to use the same technique I always use, which is doing minus 0.5 on the math random. This way, we get a random value that goes from minus 0 to positive 0, negative 0 to positive 0, and we multiply this by the randomness. What do we get? We get this. All right, so now it's centered. It's a little more realistic, but still I'm not convinced of the result. The problem is that the random value is like constant. You can have as negative as positive, and it will just be on that on those minimum and maximum value for every axis, and you get some kind of square at the end. If you look right here, you see that it's kind of square, you see? We don't like that. What we want is to have most of the particles to stay at their base position and just few ones that goes further, and even less that goes even further, and even less that goes even further. What we want is to have, let's say we have a particle here. We want to have some particles like there, lot in the center, a little less on the outer, and even less going far. All right, we want to have a lot in the center, like this, and less on the outer. How can we do that? It's actually pretty hard. It's something that to me is still hard. We have a random value. Let's do some drawings yet again. So we have some random values like this. Our random values can go from, let's say 0 to 1 and 0 to 1. So below, I'm going to draw some random values. So I'm going to have, if I get 0.5, so I'm going to just write 0.5. This one will be 0.75, and this one will be 0.25. Let's say we get those random values, all right? We were lucky, we got 3 values, which is 0.5, 25, 0.5, and 0.75. Currently, what we get at the end, well, it's those values, there is no surprise, we get this, this, and this. So this is the result we are currently having. So we have, I'm going to draw, let's say, a white line, yeah, like that. So if I get 0.25, well, I get 0.25. All right, no secret. We get something like that. We get something like that. Okay, and we get something like that. Okay, cool. What I want is that if I get 0.5, I get something more like this. All right, or even less. I want to have control over it, actually. I want something like this. If I get 0.25, I want something like this. But if I get something closer than that 1, I want something that can reach 1, all right? And if I get a value that goes, I don't know, like 0. So it's going to be 0.9, I want to be very close, like maybe over there. And at the end, what I want is this. See this shape? It's really hard to draw. Yeah. Okay, not bad. Okay, this one is fine. I want this. And I want to have control over this, like squeezing the line. Instead of having just this, the straight value, I want to be able to squeeze the value like that. So that all the values I get, like below those 0.75, I will get something really low like that goes there. And some of the values above will be able to go that far. So if I get 0.9999, well, it will be very close, like somewhere over there, but the other value will still keep a low result. And there are ways to do that. What we can do is use the power. Let me check if that's the rest. Yeah, that's it. We're going to use the power. The idea is that if you do, let me show you with the console. You can do power. So if I do 2 power of 2, well, it's 2 multiplied by 2. All right, this is the power. 2 power of 3, it's 8 because it's 2 multiplied by 2 multiplied by 2. We do it 3 times. If I do by 4, you get 16 because it's 2 multiplied by 2 multiplied by 2 multiplied by 2 again. So 4 times. All right. What we are going to do now, instead of that, we have a math random. So this is the math random. We get a value like, let's say 0.5. Okay, we got lucky. And here we are going to play with the power in order to crank the value down. And as you can see, if I use 1, so it's 0.5, we get 0.5. But if I use 2, I multiply 0.5 by 0.5 and we get a lower value. Okay. And if it was, I don't know, more, let's say 999, well, we get something really close to 999. But if it's 0.1, we get something really close to 0. And we get exactly what we did here. We get this cranking, this pushing the value down like this. So if I have 0.25, you see I get 0.15. So it's somewhere over there. It's less than the, 0.25. It's 0.06. So it's less than the original value. This is our original value. We get less. If I get 5, I get less 2. If I get 75, it's slightly above 0.5 and we can control this with that number. If I want to crank the value like the purple one, I would just put 3 and it will be even lower. I will get even lower value. All right, so this is one way of doing it. We want control over it, so we are going to create a new parameter. So let me push back this over there. Yeah, okay, that's it. Go back to our code, add a new parameter, and I'm going to call it randomness power, because it's about the randomness, but we will use a power on it. And I will use 3 just to start, and as always we'll be able to tweak it. So go back down to the tweaks, create randomness power. It's in camel case. The minimum will be 1. You cannot go below 1. We will have a strange result, and the maximum will be 10, and we will want to have a small step in order to control it. So the idea is that if we have 3, well, the particles will be condensed at their center, and if we add more, there will be even more squeeze condensed at the center, and if we add less, we will get this result. So yeah, let's use that. We can use the power by using math pow, I don't know how you say it exactly, and we are going to use it on the math random. All right, the problem we have here is that you cannot do it on negative value. You will get really strange result. Like if I do this, sometimes I will get a negative, positive. You will have a really strange value depending on the second arguments. See, if I have 2, I get a positive value because negative multiplied by negative, you get a positive value. And if I have 3, I get a negative value, and we will have bad result about that. So to fix that, what we are going to do is to randomly, we are going to use a power only on positive values, so on values between 0 and 1. So no surprise, we get a positive value, and randomly we will invert the value. Okay, so let's do first the first part, which is math pow math power, the math random, and in the second argument we use the parameters randomness power. Okay, we see the result, we get something like that, which is great. We have this kind of randomness I'm talking about, where things are condensed. Here you can see that if I increase it, we see that I get a lot more of particles at their origin inside the branch and less on the outside. So we have control over here. The problem is that, so currently the values are only positive, all right? Which is why we get this strange angle. So to fix that, we are going to randomly divide it by, multiply by -1. And to randomly multiply by -1, follow me on this, we are going to do multiply by and math random inferior to, or superior, let me check the example, you can do, inferior to 0.5. We use the ternary if, and it's going to be 1 or -1. What I did here is it's like an if inside a statement, inside an assignation. You do a test, it's like a if. If math random is inferior to 0.5, so it's like asking a question. You can do that in many languages. And if it's inferior, so it will happen statistically 1 in 2. And if it's the case, we will get 1. And if it's not the case, so if it's false, we will get -1. This way, you will just test randomly and negate the value if so. So we save, and as you can see, it's now working. It can be as positive as negative, and we can play with the power. So right now, the things are condensed at the center of the branches, and right now they are not, like it's fully random. You can control this, which is great, looking good. We are almost there. What we need now is to add colors, and we are going to add cool color, okay? We could have just put one color, like color, I don't know, some reddish value like this, maybe like that. And we get a cool result, but what I want is to have a different color in the inside from the outside, all right? So I want maybe something like, let's say it's probably more hot on the inside because there is a lot of activity. So it's going to be kind of orange, red. I'm not an expert in that thing. And on the outside, it's going to look blue because it's cold, maybe. I'm not sure there is a temperature difference because it's space. It doesn't work like that. Anyway, I want orange at the center, blue on the outside, and a mix between orange and blue between the center and the outside. So first, let's create those. Remove the color if you add it. And we are going to have a different color for each vertex. So parameters, we are going to call it inside color. Equal, you can use my colors, but you will be able to tweak them as always. We are going to use the outside color. It's going to be that one. And we can add them to the debug panel. And don't forget that if it's a color, you have to use add color. So I can duplicate this. I'm going to call the method add color. It's going to be inside color and nothing else. We don't have minimum value, maximum value. And this one is going to be outside color. And we get this, all right? It's orange and blue, and you will be able to tweak them right after. So it's not working, obviously, because we need to use them. What we are going to do now is notify the material that we are using those vertex color, because we are going to add attributes. So we do vertex colors. It's like we did in the particles lesson. Vertex color true. So right now, the WebGL is supposed to use those vertex color, but we didn't provide those. So what we need to do is add a new attribute, so we can do it there. Instead of repeating all this like below, we're going to use the same loop. All right, it's the perfect opportunity. So we are going to create a new array. It's going to be colors. It's a float 32 array 2, and we need 3 values because RGB, like the position, which is great. This were about the position, so you can do like position, and we are going to talk about the color. So we can do color. And yet again, what we will do is simply put one value. So it's the X, so the R. X is R, right? X, Y, Z, now it's RGB. It's the same actually. We're going to create a red one just to see if our attributes, color attributes is working. So X, Y, Z, and I'm going to use 0 and 0. So we get red, so it's a full red, no green, no blue. And obviously you can remove this one. I usually let it, but you can remove it because it doesn't make sense. Let's remove this one too. All right, I forgot. We save nothing because we forgot to add it to the attributes, and to add it to the attributes, we can duplicate this part, name it color, it's singular, and use the colors, so plural array, because we called it colors with an S. Careful with singular and plural. You can do a lot of mistakes. And it's working great, looking good. Kind of a diabolical, evil thing, doom thing. Let's change this. So, what we are going to do now is create the base color. So not inside the loop. Move yourself out of the loop. We can do it like right after creating the colors array. We are going to create instance of 3GS color. Right? It's this famous class we used a lot. Using those parameters. So we create the color inside. It's going to be new 3 color, so it's the color class from 3GS, parameters, and we are going to use the inside. Is it the inside color? Yeah, it's inside color like this, and create the outside color. Outside color. Did I get it right? Yeah. You will see why shortly. So we create instances. You can log it if you want, but anyway, if we didn't have any error, that's fine. We get a color class and we get those values. Okay, looking great. What we need to do now is mix those colors, all right? Because we want orange at the center, so we want the inside color. We want blue on the outside, so it's the outside color. Great, but what we want now, sorry, did I do wrong? So yeah, it's color inside. I should have called it inside color. Anyway, it's to mix the value depending on the radius. Right? We will get the distance. We want something like 0 if it's at the center, 1 if the particle is at the outer, and do a mix between this color and this color depending on this value from 0 to 1. So, how can we do that? Well, what we are going to do first, before, there is a cool method on the colors. I can show you that. It's here. There is the lerp. I can show you lerp. Yeah, that's it. The lerp will take the base color, so we can take the inside color and lerp the value, meaning it will interpolate to the another value. So we will lerp to the color outside, and we will provide a third value, a second parameters that will be how much from this other color we need. So if we take this base color and lerp it to this color and we provide 0, it will be the base color. If as the lerp value we provide 1, it will be this value. And if we provide 0.5, well, it will be a perfect mix between those two values. So we could do something like, don't do it, I will just show you. Color value, lerp, and we provide the second value, don't do it. If I do this, I will get a perfect mix between this value and this value. But be careful. When you do that, you are changing this value, the color inside value, the first value. And if you do that, you will change it, and then the next particles, we have a wrong value. So we need to create a clone of this value in order to not change the base color inside. So what you have to do is position yourself inside the loop that creates each particle, and you will create another color inside. So we are going to call it mixed color, and we are starting from the color inside value that we are going to lerp, but we don't want to modify this one, so we are going to clone it. And you have clone on many classes of 3GS. It will just create a new instance from this base instance so that we can change the mix color which is a clone of color inside, without touching to the base color inside. And then what we can do is lerp this value, and we are going to lerp to the color outside. So we want to lerp to the color outside to interpolate in order to take the color from the color outside. And we need to provide a value from 0 to 1. Let's start with 0. Okay, we just want to test these things first, and then we are going to use this mixed color. Instead of putting 1, 0, 0, we do R, which is from 0 to 1, G, and B. And because we put 0 here, we'll get the orange color. And if I put 1, well, obviously, I will get the blue color. And if I put 0.5, you guessed it, I get a mix between those, which get this strange color. But I don't want to put a value there. I will use the distance from the particles to the center of the scene. The galaxy, it's the same. What I can do, because I need a value between 0 and 1, I can use the radius, which is over there. So this is the radius of the particle. Radius, but be careful. The radius currently goes from 0 at the center, 1, 2, 3, 4, 5, up to the radius here. So it's wrong. I need something that goes from 0 to 1. What I can do here is divide the radius by the base parameter. All right, we are going to do parameters radius so that we get something from 0 to 1. And that's it. And that looks great. What a beautiful galaxy. Add more particles if you want. You can tweak the spin. Yeah, it looks great. You can play with the randomness. Yeah, this one is really cool. And you can change the color because we can. Let's do it. Yeah, this one looks great. Maybe a greenish galaxy. Oh, it looks bad. Anyway, that's fun. I really like this one. With a cyan color, it looks really great. Great. I have to stop playing with it. All right. And it's done. We did it. I know it was hard. There was a lot of mathematics. We did it in something like 1 hour. For me, it took even more because I have to find the perfect tweaks, the perfect progress, separate everything. So it takes time. Maybe you will spend like a full day, and you will get not a result as beautiful, but still you will practice. And the next time you will try to do this, it will be even better and better and better. Anyway, what you can do is go even further. We have to stop there because it was way enough for the lesson. But what you can do is add more tweaks because we can have more parameters in the tweaks. I'm seeing that there is a lot of particles at the end. The randomness is doing its job, but there is a lot of particles. Maybe you can use the same technique we did with the power in order to have more particles at the center than the particles on the outside. I'll let you do this one. You can test other galaxy shapes if you know them. You can use a texture. Maybe you can put like bigger particles, but with textures and maybe less particles, or you will have performance issues. You can rotate the galaxy. Let's rotate the whole galaxy. You can create multiple galaxies and see them collide, stuff like that. Anyway, in a later lesson, much later, we are going to learn how to animate each particle. Meaning that each particle will have its own animation. And the animation will be the spin animation. So we are going to put this spin value to 0, and then all the particles will start to spin, but at a different speed. And it's going to be in the shaders lesson. See you in the next lesson.